Okay, welcome back. Uh, Today we're going to work on Intermediate Algebra, Martin Gay, 4th edition, and we're going to be doing section 3.1, which is about XY coordinates. So I put up the XY coordinate here, so I think that's going to help. And we're going to do the even numbers between 2 and 34. Now, number 2 says, plot the ordered pair on a given rectangular system and name the quadrant or axis in which the point lies. The first one is 2, comma, -1. Okay, so by convention, the first one is always the x, or horizontal axis. So that's 2, and then we go to -1 on the y, and we get a point right there. That's 2, comma, -1. The next one is, and that's known as quadrant 4, simply because the quadrants are numbered 1, 2, 3, and 4, and that's just conventional. Didn't have to be that way, but that's the way I was taught to number the quadrants. -3, -1. Okay, so you go x to -3, y to -1. There you go, that's the second point. Next one is -2, comma, 6 1/3. Okay, so x is -2, y is 6 1/3, so it's up here. 1/3, it's actually going to be hard to be precise about that. I'll take away the quadrants since it's getting in the way of the points. The next one is -2, comma, 4. So you go -2 and up 4. Okay. Next one is -4.2, comma, 0. So you go -1, -2, -3, -4.2, and then you go up to 0. And you end up right on the axis there. Okay, I can put it on the axis, but it's hard to see it because the axis is black. Okay, that's question 2. So I want to erase this without losing my coordinate system. This is graph paper, really. That's what we got. Okay, now we'll go to number 4. Given that x is a positive number and y is a positive number, determine which quadrant at each point lies. Okay, so -x, comma, y. Well, if you go to -x and positive y, that puts you in quadrant 2. Okay, now number 6. 0, comma, -y. So x is 0, y is -y. That's going to be somewhere on the negative x-axis. I'm sorry, the negative y-axis. Okay? I call it the negative y-axis because it's the part that's below here. It's the y-axis, but I call it the negative y-axis because it's the lower part of it. Okay, and then 8 is 0, comma, 0. That's the point right here, which is known as the origin. Okay, that's on the x-axis, it's on the y-axis. It's not in any particular quadrant, but I call it the origin. Okay, now let's go to number 10. Number 10 says, create a scatter diagram for the given paired data. And number 10, it has postal rates for a 1 ounce first class letter. So they have 2005, it was 37 cents. Oh, this is a very interesting table. And then in 2006, it was 39 cents. It's going up 2 cents per year. 2007, it was 41 cents. 2008, it was 42 cents. You see this is going up at about 4% every year. So first class postage rates in this period of time have been going up pretty rapidly, and it's 42, 44. This is why you want to buy the forever stamps, because nobody wants to have to worry about buying a stamp and then having the next year where it won't work. Okay? Now, In order to do this plot properly, what we're going to do is we're going to assume that instead of being 1, 2, 3, 4, 5, now we're going to make that 10, 20, 30, 40, and 50. Okay? Oh, I lost my black marker because I don't have my purple one, but that's okay. Now, and in 2005, we're going to assume that this is 2005, 2006, 2007, 2008, 2009, okay? So in 2005, it was 37, so that would be 10, 20, 30, 37. That would be right about there. 2008, it's 39. So what I need to do is, unfortunately, I put this in the wrong place. All I need to do is take the lower one off, put it up here, 2009 at 44. And I'm going to have enough room. You see, the idea is every year, it only goes up by 2. So by the time you get to 2009, it's 44, from 37 to 44. That's only up about here. And each year, it's going to be in between, about equally spaced. So that gives you a scatter diagram. And you can see that these fall on a line. They are on a line because it's going up linearly. Every year, it's by the same amount, or 2 cents. Okay? And this would be, obviously, I had to change the axis a little bit to call that 2005, 2006. Okay? Okay, that's fine. Now, that was number 10. Now let's go to number 12. Determine whether each ordered pair is a solution. Y equals, okay, I guess that's just fitting on. Y equals negative 2x plus 7. And they want us to test this for the points 1, 5 and negative 2, 3. Okay? Well, the way we're going to do this is by simply plugging it in. So for the first case, we're going to plug in 5 for y and 1 for x. So this is negative 2 plus 7. And that's going to give a check. That's correct. 5 is equal to negative 2 plus 7. And then for the second point, we're going to put in 3 is equal to negative 2 times negative 2. Well, that's just negative 2 times negative 2 is just positive 4. So let's just write it before. Okay? And then plus 7. We have 3 is equal to 4 plus 7. Well, that's incorrect. Okay? So that's not a point on that line. Okay? Okay, number 14. 5x minus 3y. We want to check the points, equal 9. We want to check the points 0, 3 and 12/5 and negative 1. Okay, well, first let's do 0, 3. So we put in 0 for x. We put in minus 3 times 3 equals 9. And that's incorrect. So this is not a solution to that equation. This is just by plugging it in and evaluating the expression. We can see that it's not a solution. Okay, let's try the second one. 12/5 and negative 1. So we have 5 times 12/5. Now it's minus 3 times negative 1, so that's just plus 3. Okay, equal to 9. Now the 5s are going to cancel, and it's going to say 12 plus 3 equals to 9, which of course is not correct. That's also wrong. Okay, 12 plus 3 is 15. Okay, now we go on to 16. Y equals 2. Then we have the points 2, 5 and 0, 2. So this is x and this is y. So we plug in this coordinates into this equation. The first will be 5 is equal to 2. Well, that's wrong, so that's not a solution. And then the second one, x is 0, y is 2. So when we plug in the second point, we get 2 equals 2. So that is a solution to that equation. That's 16. Okay, so now let's go to 18. So let's graph each linear equation. Y equals, no, I'm sorry, y minus 2x is equal to 4. Now, what's the easiest way to plot this? The way to plot a straight line, you need to find 2 points on the line. That's the easiest way to plot it. Another way to plot it would be to find 1 point on the line and to have the slope of the line. Okay, but I think in this chapter, I think the way that they show is a way in which you try to find 2 points. So we're going to try to find the x-intercept and the y-intercept. That's pretty good. So to find these 2 intercepts, first, to find the y-intercept, you set x equal to 0, and then solve this equation. So if x equals 0, you get y is equal to 4. So that means this point here is actually on that equation. That's the solution to this equation. Now, if you put y equals to 0, that's the x-axis. So if you put y equals to 0, you get negative 2x equals to 4, or x equals to negative 2. So what that means is this point is also a solution on that equation. And that means the line is just going to be, you get a straight edge and you simply connect those 2 points. It's got a slope of negative 2, it turns out. That's because it goes up, 4 and over 2. That makes a slope, which is the ratio of the so-called rise over the run. But they're not asking for the slope. They just want you to plot the line. So that's one way to plot the line. Okay? Now in this case, what I'm going to do is I'll try to leave these points on here. Well, because I don't have an easy way of taking these off. That's the problem. I guess I'll try to do the best I can. Okay? And it's going to get a little messy, especially since I lost my black pen. Okay? What I'll do is I'll just put it in with the other color pen, just to fill it in. Okay, let's try the next one. X1 is number 20, and that's 2x plus 4y equals 8. Okay? If x equals 0, then this says 4y is equal to 8, or y equals 2. When x equals 0, y is 2. And then when y equals to 0, we have 2x equals 8, or x equal to 4. So when x equals, when y equals 0, x is 4. So that would be over here. So actually, in this case, we're going to get a very similar line, only it's turned on its side. It's going over 4 and up 2. Okay? That actually is a slope of 1/2, because the ratio of the rise over the run is the ratio of 1 to 2. Okay, let's erase that away. And I can put this back in, so we can conduct the rest of the problem. I don't want that. Okay, that was number 20. So let's go to 22. 22 says y equals to 5. Y equals to 5 is just a straight line up at the height of 5. Because y is equal to 5 everywhere, regardless of the value of x. That's a horizontal line. This is the formula for a horizontal line. Okay. We didn't need 2 points in that case. Okay. Now let's go to 24. X minus 4y is equal to 8. Okay? When x is equal to 0, we have negative 4y equals 8, or y is equal to negative 2. So when x equals 0, y is equal to negative 2. That's this point right here. And when y is equal to 0, we have x equal to 8. We just plug in 0, and the equation reads x equal to 8. So when y is 0, x is 8. That's the point over here. So this is a very shallow slope line. I didn't draw it very straight, but you just get a ruler and you put it in. And it's hard to do this without a ruler, or at least a straight edge. I should have done better. Let me see if I can do better. Just trying to straighten up, put a straight line between them. The slope on that is the ratio of 2 to 8. That's a ratio of 1 over 4. So that would be called the slope of 1/4. Let's see if I can. Okay. Put the line back in. Right here, go to the next problem. Number 26. Y is equal to negative 4x. Okay, this is an interesting one. If we put x equal to 0, then y is equal to 0. If we put y is equal to 0 and solve that, we'll get x equal to 0. This is the form of an equation that goes through the origin. In order to get another point, we can't use the x-intercept or the y-intercept because it crosses them both at exactly the same point. So it would be very easy to put in something like x equals 1, put in x equals 1, and then you get y is equal to negative 4. And that'll give you the second point. And that allows you to sketch it. Okay? That has a slope of what's known as negative 4. Because the ratio of the x change in x to the change in y is the ratio of 4 to negative 1. Okay, anything that goes up to the right is called a positive slope, and whenever it slopes off like that, it's called a negative slope. Positive slope, negative slope. That's just conventional. Slope is defined as the change in y divided by the change in x. When, as you move across from smaller values of x to larger values of x. So you just remember that this is defined to be a slope that's positive. Okay, now let's go to the next one, which is y equals to negative 3. Okay, so you go down to negative 3, and then you just draw the line. This is a horizontal line at the height of negative 3. Okay, now let's go to 30. 2x plus 3y equals to 9. Okay, well, let's set x equal to 0 to find the y-intercept. That would be 3y equal to 9, or y equal to 3. That is the so-called x. That's when x equals 0. So that's where it intercepts the y-axis. That will be right here. And then we set y equal to 0. We'll get 2x equals 9. That's the so-called x-intercept. And that's going to be equal to 9 over 2, or 4.5. So that's going to be right here. Okay. And that looks like this. The slope of this is negative, and it's the ratio of 3 to 4.5, which doesn't come out to any particular nice ratio, but that's what it is. They're not asking for the slope here. I just happen to be throwing it in. Okay. Now let's go to 32. 32 reads 3y equals x minus 3. When x equals 0, 3y is equal to negative 3. Okay, that's for x equals 0. And so y is going to be negative 1. Negative 1. 3 times negative 1 is negative 3. X equals 0, y is negative 1. That's this point right here. And then if we put y equal to 0, we'll have 0 is equal to x minus 3, or x is equal to 3 by moving the 3 to the other side. So when y equals 0, x is 3. That's this point here. Okay, this has a slope of 1/3. Because the ratio of the rise, which is 1, to the run, which is 3, is 1/3. That's positive slope, but it's less than 1. That's called shallow. Shallow slope, and that's called a steep slope. Okay. But all we have to do here really is actually just plot the line. Okay. Okay. Now, let's go to the next and last problem, which reads y equal to -5/2. Well, -5/2, that's -2.5. So you go down to -2.5, and that you just draw a horizontal line, and that's a horizontal line in the y-axis. Okay, and that's all for section 3.1. So, thank you, and I'll see you next time.